And now just a quick video, because I know the way these can be asked on the exams can be a little bit confusing for people sometimes. So just kind of contrasting where you're using de Moivre and raising to a whole number power and when you're raising it to a fraction to get roots. So I think these are taken from the actual exam papers. This is 2017, this is a little bit earlier. So you're told in the start of the question that z is equal to minus root 3 plus I. So there's your complex number. And then one of the parts of the question is use de Moivre's theorem to write z to the 4 in its simplest form. Okay, or I think it comes up that year as use de Moivre's theorem to write z to the 4 in the form a plus b root ci, where a, b, and c are elements of z. So just, you're given z and you're asked to find z to the power of 4. So you are going to take your minus root 3 plus I, so that's your z, and raise it to the power of 4. So you are raising a complex number to some power. We use de Moivre to do that. So you're going to convert this into polar form and then power of 4, and you'll use de Moivre, okay? But it's just polar form here. So when you're raising to the power of 4 like this, it's just de Moivre. You don't have to worry about just polar. You don't have to worry about the general polar form. That's the one on the other side of the page. Just in its simplest form means rectangular form, okay? So the kind of default here is you'll be going back into rectangular form for a lot of answers. When it came up, rather than saying in its simplest form, and this year they said in the form a plus b root ci. So that's just in rectangular form again, where a, b, and c are elements of, don't get confused here, elements of this capital Z with the double line through it. That just means a, b, and c will be integers. Okay, so don't mix up, I suppose, the little z they use to denote, to label, to name complex numbers with this capital Z with the double line on the diagonal, which means integers. All right. This one over here then, use de Moivre's theorem to solve the equation z squared is equal to minus 1 plus root 3i. Give your answers in rectangular form. So in this question, you are given z squared is equal to minus 1 plus root 3i. Okay, so you are given z squared and you're asked to solve it. So you're looking for z. So you're looking to go from z squared to z. So this is the one where you'll get the square root of both sides. You'll end up writing minus 1 plus root 3i to the power of a half there. So to solve these ones, this is where you need to change this into general polar form. Okay, and you'd be subbing in, because there's two solutions, n equals 0 and n equals 1 at the end of the question. Okay, but just if you're given z squared in the question and you want z, that's where you're using de Moivre to get the roots. That's where you'll have a fractional power. That's where you need to use general polar form. Okay, they say solve the equation here. They could say find the roots as well. It's the same question. They didn't explicitly say z is an element of c here. They could do that. C just being complex numbers, c with the kind of the line down there, and then give your answer in rectangular form. That's the default that they wanted in rectangular form. So even if that wasn't there, I'd still convert your answer back from polar to rectangular at the end. But that's, look, rectangular form there, a plus b root ci there, simplest form there, all mean the same thing, all used on the exam in the last few years.